x as an exponent, which is a little bit new to us. So we can write an exponential function in this form. We have some number in the front a, it's being multiplied in. We have our value, our base here, the c value is our base to the power of b times x minus h plus k. We can actually apply our laws of exponents to simplify this into what we would call our standard form, and this is our standard form here. And standard form, we know from previous examples and previous functions, is important because we use it when we are solving equations, we use it when we are graphing. So we have that value a in the front. It would be different from the general form version of a. We have a base c. We have just to the power of x, so we only have x as our exponent, no value b, no value h, plus k. So how do we take a function in this form and convert it into this form? So I've asked us to convert this equation into standard form. And we can see here that this is our value of a. Our base right now is 3. We have a b value of 2. We have an h value of negative 2. And we have a value of k that is 7. So how do we go about applying our exponent laws to simplify this first term here, that 4 times 3 to the power of 2 times x plus 2? Our very first step is to bring that power of 2 that's being multiplied inside. Why are we allowed to do that? Because we know that if we had something like this, we could simplify it to look like this because we would be multiplying those exponents. And we can go backwards as well. So we can go from this backwards into this. It doesn't matter which direction we apply the rule. So that is our first step. Why are we doing that? Because we can actually convert and write it like this. Now our base is no longer 3. Our base is 9. Next thing we'd like to do is to somehow simplify this so we just have a power of x. We don't want that plus 2 anymore. So we're going to apply another exponent rule, and it's this, that if I have c to the power of x plus 1, I could just write it like this. And actually, we're used to applying this rule also in the opposite direction, that if we have two things with the same base, we would just add their exponents to simplify. And we can apply that rule in both directions. So right now, we have c to the power of x plus 2 in our case. Let's separate that into two different exponents. So I have 4 still in the front, times 9 to the power of x, times 9 to the power of 2, plus 7. Now, we want to simplify further because we know that in our standard form we only have one value a out in the front. So why not take this 9 to the power of 2 and simplify it to be 81. And then we can actually multiply that by 4. That gives us 324 and leaves us with just 9 to the power of x plus 7. So we have highlighted in green here our standard form. So our value of a out in the front here is 324. Our base, c, which is also another parameter, it's a new parameter to us. Our base c is 9. And our value of k is 7. Now that we understand how to convert from any form into standard form for an exponential function, let's take a look at graphing. So we would graph an exponential function by using our standard form. So we want to make sure that it's in this standard form here. And our curve of an exponential function will pass through the point with the coordinates 0, a plus k. So our x is 0 and our y is going to be equal to a plus k. One thing to know about that is that it's going to be our y-intercept. It's the y-intercept because we know the x value is 0 and the y value is whatever. In this case, it's going to be a plus k. That's going to be very important because it's going to let us find the rule of our function when we're given a picture of the graph. Our graph will also approach a horizontal asymptote, and the equation of that asymptote will be equal to k, y equals k. Remember that an asymptote is something that our graph is approaching, but will never actually reach. In this case, we only have one asymptote. We actually were used to working with both a horizontal and a vertical asymptote when we were working with rational functions. So this isn't a new concept for us. Let's take a look at a graph and pick out some of those key values that we just discussed. So we have a graph of a function here. I haven't given you the rule, but there are a few pieces of information that we can automatically pick out. The first thing is that we have our horizontal asymptote here. The equation of that is y equals k. In this case, it's at 2. So the equation of our asymptote is y is equal to 2. Our value of k that shows up in the equation in standard form is equal to 2. Now, I know that you can't see the grid, so it's hard to make this assumption, but I can actually tell you guys that the coordinate at this point is 0 and 5. That's also important for us because that tells us that a plus k is also equal to 5. So that gives us information about the value of a, because we already know that the value of k is 2. So let's take a look at actually solving step by step to find the rule. So if we're given some graph, like this one on the right, and we're asked to find the rule of this function. The first thing is to recognize the shape, to realize that it's an exponential function, that they have this distinctive curve with a horizontal asymptote. And we're going to find the equation of the asymptote, the y-intercept, and one other point, any other x and y. So the equation of the asymptote here is negative 3. And that's our value of k. Our intercept is at 0 and negative 2. And another point here is at 1 and 1. Okay, so we have y is equal to negative 3. We have our point, 0 and negative 2. And we have another x and y value of 1 and 1. We're going to determine our parameters a and k. Well, we know that k is equal to a negative 3. And we know that a plus k is equal to negative 2. So that's going to give us some information here. Let's do a little bit more solving. A plus a negative 3 equals negative 2. So a is equal to a positive 1. And then the last thing is to substitute the coordinates of the point into your rule to solve for c. So once we have our values of a and k, we need to figure out what c is. So I'm going to run out of a little bit of space here. Let me see if I can extend my page. Perhaps I cannot. We are going to use this form of our rule. So y is equal to a times c to the power of x plus k. I'm going to fill in my value of y, which is 1, from my point 1 and 1. Going to fill in my value of a, which is also 1. Going to leave c as it is, because I have no idea what it is. I'm going to look at my value of x, which is 1, plus k, which is a negative 3. And then we're going to solve. So we're going to solve and simplify and figure out what our value is. So we have negative 3, so we're going to add 3 on both sides. It gives us 4 is equal to c to the power of 1. So c is just equal to 4. So if we want to fill in our final rule here, we have y is equal to our value a, which is 1. So we actually really don't need to write it down. Our base c is 4 to the power of x. Our value of k is a negative 3. And that's the method we're going to use to solve for the rule of any exponential function.